Hey students, this is Mr. Bornheimer. And if you go ahead and look at the screen, this is going to be your Math 7 lesson for 7-2. So Chapter 7, Lesson 2. This lesson focuses primarily on the relationships and the way that we look at these geometric shapes called angles. All right, here we go. Angles are a combination of rays. Okay, so if I were to draw, and look on the screen here, if I were to draw a ray like that, it has a point at the end, it has an arrow that would go on forever, and if I were to join another ray at that same point, what is formed is called an angle. Okay, this area in between the two rays this area in between the rays is the angle area, okay? Now, when we are looking at different angles, angles come in all different shapes and sizes. So you might have angles that are real thin, or you might have angles that are bigger, like this, or you might even have angles that are really open, okay? Like in here, here, here. So we oftentimes like to put arcs inside the area between the rays to indicate the angle that we're talking about. But really, like on this bigger one, this is also an angle, okay? So an angle is the space between two rays, and we can measure those, basically these angles, in what we call degrees. Okay, degrees. So let's go ahead and take a look at what a couple different angle degrees look like. First of all, if you have an angle that has of two rays that are perpendicular, okay, that means that one kind of butts right into the other, then what is formed is something called a right angle. And right angles are 90 degrees. What that means is that if I have two perpendicular lines, like so, and I start right here, and I were to go all the way to here, that the whole area in between the two rays, okay, that traveling from one ray to another, I would go 90 degrees. This actually helps us to understand other types of angles that we're going to look at today as well. So I might have the 90-degree angle there, but then what happens if I were to have and that's not drawn very well. Let's go ahead and clean this up a little bit. Something like this. So I have a perpendicular line here and a perpendicular line here. So if I were to go from here to here, that's 90 degrees. But then if I were to go from here to here, that's another 90 degrees. So if I were to go the whole distance from here all the way to here, that would be 90 plus 90, which is 180 degrees. Okay? So angles have degree measurements, and they can be anywhere from a little bit to a lot. But the largest angles are no angle is going to have degrees greater than 360. Because if I had, let's go ahead and draw another diagram here. If I have two intersecting lines, and they're lines, I'm going to put arrows on the ends. I have currently 4 rays. Okay, I have 4 rays. And we're going to name them so that we can, this is kind of review. So I have 4 rays. I have a ray here. I have a ray there. I have a ray there. And I have a ray there. So I have 4 rays. I also have 4 line segments. From A to C is a line segment. From A to D is a line segment. From A to E, stopping at E, is a line segment. From A to B is a line segment. I also have 2 lines. I have line AE that is perpendicular because it intersects with BD at 4 right angles. One right angle here, a right angle there, a right angle here. Okay, and I'm going to erase that so it doesn't interfere with A, and a right angle here. Which means that I have 90 degrees and 90 degrees and 90 degrees and 90 degrees. And now I'm back to where I started. So the biggest angles I could have to be somewhere between 0 degrees, which is over here, and not 90, not 180, not 270, but if I were to go all the way around, 360 degrees. Okay? So angles are going to be anywhere from just a little bit to 360 degrees. Now, most of the angles we're dealing with in this particular class will be between 0 and 180 degrees. Okay? There are, however, when we're looking at angles, special types of angles. So let's take a look at 2 lines that are intersecting. So here's an angle, or there's a line and there's a line, okay? And they're intersecting at point P. I'm going to call this line L, and I'm going to call this line M. So I have line L intersecting line M at point P. Okay, that's what's happening here. So line L is intersecting line M at point P. And as a result, there are 4 angles being produced. Okay, I'm going to go ahead and number them. There's angle 1 right here, angle 2 here, angle 3 here, and angle 4, not to be with the P there, right there. Okay, I'm going to go ahead and erase point P just so it doesn't get in our way. But that is still point P there in the middle where they intersect. Now, there are some special relationships here. Okay, very special relationships. First of all, you sometimes will have angles that are directly across from each other. So let me show you what I mean. I have an angle right here. Okay, that's called angle 1. And directly opposite angle 1 is the yellow highlighted angle, angle 3. Now, there is a special rule that states that these 2 angles, because these lines are intersecting, are what we call congruent. Okay, let me go ahead and write this down for you. I'm going to write it off on the right-hand side here. Angle 1 and angle 3 are congruent. What that means is that they are the same. They have the same measurement, okay? The statement we would use for this looks something like this. The measurement of angle 1. What that means, let me kind of zoom in on that. All right. This little icon right here means measurement. And this little icon right there, that means angle. And the 1 right there in the end, well, that's the name of the angle. So we have the measurement of angle 1, okay? The measurement of angle 1 equals the measurement of angle 3 because they are directly across from each other when the two lines are intersecting. These types of angles have special relationships called vertical angles. Vertical angles are angles that are directly opposite each other. So 1 and 3 are vertical. And actually, if you look carefully here, I'm going to kind of do the same thing here. 4 and 2 are also directly opposite each other. So they're also vertical angles. And because they're vertical angles, the measurement of angle 2 equals the measurement of angle 4 as a result. So we would say that angle 2 and angle 4 are also congruent. So we would just change these two numbers to 2 and 4. So we can also look at the types of angles and how they're useful. All right? But that's not all. All right? Angles okay, here we have a diagram. And we have angles here, and we have angles here. Now, sometimes when we're labeling angles, we use arcs. And if the angles are different, the arcs are going to look different. So notice that there is an angle here that has one arc, and there's an angle here that has 2 arcs. Those 2 angles are different. We're going to go ahead and put some points on this figure. We're going to label it A, B, C, and D. Now, if I wanted to label the left-hand angle, I would say that that would be angle A, B, C. Okay, so I'd start at point A, I'd work to B, and I'd go to C. That's how we would label an angle using points. So unlike the last figure where we just numbered the angles, or in the previous figures where we just kind of said their measurements, we can also label angles using points. So angle ABC is this angle right here. All right. Now, there's also some special things about the way we name angles. The point, if we go all the way back to the beginning here, the point in the middle, okay, where the 2 rays are joined together, this point right here, that's called the vertex. Okay, and that actually kind of looks like vortex, so I want to kind of erase that. The vertex. The vertex is always the center point of the angles. It's where the angles hinge. Okay, so when we're naming angles, like so, when we're naming angles, we name it so that the center point is always the vertex. So I would never label angle ABC angle BAC or angle ACB. Those are definitely not the way that I would name that angle. Because in this one, A is in the middle. A is not the vertex. And in this one, C is in the middle. C is not a vertex. And so therefore, they cannot be angles. So those angles actually do not exist on this diagram. Okay, there's only one way to name it. There is, however, another angle in this diagram. And if we trace it using a highlighter, it's angle CBD. Okay, so I would call that angle, go ahead and pick a different color here, angle CBD. I would not name it, okay, if I were to trace this, I would not name it DCB because I can't cut across the angle like I did there. I would not name it CDB because, again, I'm doing the same thing. So it can be named with the vertex. Oh, let me make sure this isn't CBD. It has to be named with the vertex in the middle. Okay? So the way we name our angles is really important. Notice that these two angles, angle ABC and angle CBD, share the same vertex. And that makes sense. If you looked at that diagram, you can definitely tell that the two angles share that same vertex right in the middle. Okay. Now, there is a very special relationship here where we have these two angles. And that is, if you recall from our previous diagram, if you have two perpendicular lines, or a ray and a line that meet, that are perpendicular, that the angle here is 90 degrees, and the angle here is 90 degrees, which means that a straight line, if you travel from here to here, is 180 degrees total because it's 90 plus 90. So this here would also be 180 degrees, right? Well, the same holds true in this diagram. Okay, in this diagram, to go from here to here should be 180 degrees, which means that this angle, let me redraw this figure, it's getting a little messy. Okay, what that means is, oh, that's not what I wanted to do. That's what I wanted to do. That if I travel from one side to the other, that's a total of, oops, 180 degrees. What that means is, now that we finally got there, that this angle here and this angle here, so the purple and the green, have to add up to 180. The way I would write this, if I have A, B, C, and D, is that the measurement of angle A, B, C, okay, so the measurement of angle ABC, I'm going to put a green box around it so you kind of can compare, plus the measurement of angle CBD has to equal 180 degrees. These two angles are called supplementary angles. Supplementary angles are angles that have to add up to 180 degrees. You might want to put this in your notes. Okay? There are also angles that have to add up to 90 degrees. So we know the distance from here to here is 90 degrees. Well, the yellow angle and the gray angle have to add up to 90. So if I were to label this angle, we'll call it W, X, Y, and Z. So angle ZWY, which is our gray angle, ZWY, when added to angle YWX, which is my yellow angle, has to equal 90 degrees. We call these angles, when they add to 90, complementary angles. And complementary angles are angles that add up to 90 degrees. So, kind of want to recap a little bit. We were talking about angles, and that the fact that there are different types of angles, and that angles are made up of two rays and a vertex. Okay, and the angles can be anywhere from 0 to 90 to 180 to 360 degrees. 360 degrees total. We talked about how when angles are across from each other, they are congruent, which means they are the same. And because of that rule, they are called vertical angles. I'm just going to write that down again. Vertical angles. I'm going to zoom in. You might want to write this in your notes. Vertical angles have the same measurements or measurement and are across from each other. Okay, so 1 and 3 are vertical angles, 2 and 4, but 1 and 2 are not, 3 and 4 are not, 2 and 3 are not, 1 and 4 are not vertical angles. 1 and 3 are, 2 and 4 are vertical angles. Okay, so vertical angles are across from each other. Then we have angles that when we name them have to be named a specific way. And when we add them up in a situation like this and they equal 180, they're supplementary. And when we add them up and they equal 90 degrees, they're complementary. Okay, now this is all to kind of help us with understanding the basics of identifying and classifying angles. So, if you look at the examples from our book, we see here some of the same things we've been talking about, that this angle has got a ray here, and a ray here, and a vertex right here. We also see that there are different types of angles, some of which we talked about, some of which we didn't. I want to draw your attention to acute angles, which are angles that are between 0 and 90 degrees. Then there is the right angle, the classy right angle. And it's exactly 90 degrees. Then we have the obtuse angle, which is this one, okay? And the obtuse angle is going to be greater than 90 degrees, but less than 180 degrees. So it's between 90 and 180. And then you have the straight line, or the straight angle. Okay, and that straight angle is the same. I'm just zipping ahead here. It's the same as this idea right here. Okay, that a straight line adds up to 180 because of the 290 degrees that would have been there, or half of a circle, which is 360, etc. So this is how we have different angles. So acute angles are small angles. Right angles are angles formed by perpendicular lines. Obtuse angles are large angles. And straight angles are, well, straight lines. We also have angles that are complementary and supplementary. Complementary angles add up to 90. So if you do the math right here on this page, 51 plus 39 equals 90. Okay, so we have that going on there with the supplementary angles. And then you have 65 plus 115, and that equals 180 degrees. And so those are supplementary. So we have complementary angles add up to 90. And supplementary angles add up to 180. So if we were to look at the example they give us right here, this multiple choice problem, it reads if angle A and angle B are supplementary and the measure of angle A is 37 degrees, what is the measure of angle B? Well, to solve this is pretty straightforward. They're using the keyword supplementary here. So they're saying you have to have 180 degrees total. And if they give you one of the angles is 37, if you subtract that from your total, okay, notice here that's what they're doing. They end up with 143 as the angle that's left over, and that would be the supplementary angle for this problem. Okay, there's also some key terms in here: adjacent angles, vertical angles, congruent angles. Okay, we kind of talked through vertical angles and congruent angles, vertical angles being angles like 1 and 3, or 2 and 4, but we didn't talk about adjacent angles. Adjacent angles are angles that are right next to each other. So angles 1 and 4 are adjacent. Angles 1 and 2 are adjacent. Angles 2 and 3 are adjacent. Angles 4 and 3 are adjacent. So those are adjacent angles. Okay, so if you're looking at your homework, you're going to see that they're going to ask you for things like identify acute, right, obtuse, or straight angles. Okay, and you can look at some of those definitions earlier in the previous pages. Okay, they're going to want you to identify diagrams where there are adjacent and vertical angles present. They definitely want you to work with the complement and supplement, where when you're working with complements, you're trying to find two angles that add up to 90, and supplements, two angles that add up to 180. Okay, and so these are some of the problems that you're going to have to do on your assignment for Monday. I want to go ahead and work through just 2 examples with you here, okay? And so it might be helpful for you, and I know this video's been moving kind of fast, it might be helpful for you to maybe pause the video, go back to any of the ideas that you might be struggling with, re-watch and re-listen to me a couple of times, just to make sure that you're getting these ideas down, okay? So to review, this lesson has covered key ideas dealing with angles that are made up of rays and a vertex. So this new vocabulary word there. We've been talking about things like acute angles, which are smaller angles, right angles, which are formed from 2 perpendicular lines, or a ray, 2 rays that are perpendicular, and then obtuse angles. We've been talking about adjacent angles. We've been talking about complementary angles. We've been talking about supplementary angles. And we also talked about how to name, identify, and look at the measures of angles. Overall, it's been a a lot of information, right? We've introduced a lot of new vocabulary. We've looked at a lot of new types of angles. So it might be to your benefit to go back and watch a couple of parts of this video over again, just to make sure that you have the ideas of these angles down. Then, of course, if you have any questions, you can always message me, okay? So having looked at these ideas, let's apply them a little bit. So I'm going to go ahead and I'm going to draw a figure here. All right, so these are 2 parallel lines. This is from lesson 7-1 when we looked at parallel lines. And I'm going to go ahead and draw there are 10 angles in this diagram, okay? So I'm just going to start going through and I'm going to start showing you some things that you could identify here. First of all, I want you to try and identify some of these things on your own. So angles 4 and angle 6 are, I want you to see if you can fill in, are what types of angles? Angle 8 and angle 7 are what types of angles? Angle 1 and angle 2 are what types of angles? Okay, so let's start with those. So pause this video, take a few moments, and see if you can answer these things: angle 4 and angle 6, angle 8 and angle 7, angle 1 and angle 2. And what you can do is you can actually scroll back in the video and pause it at this diagram right here, or pause it right now to answer these questions. So go ahead and pause right now. All right, we're back. You should have paused the video. You should have tried to answer some of these questions: angle 4 and angle 6, angle 8 and angle 7, angle 1 and angle 2. Okay, and try to identify as many things about these angles as you could. So let's look at 4 and 6. Okay, this angle right here and this angle right here. Well, first of all, they're across from each other where 2 lines intersect. So angle 4 and 6 are what we call vertical angles. And all vertical angles are also congruent angles. Okay, now we also want to look at angles 8 and 7. Okay, well, the first thing I can tell you is that they're right next to each other. And angles that are right next to each other are called adjacent angles. So I'm going to start by saying, well, hey, angle 7, they're adjacent angles. Okay, so we know that about them. But we can also see, if we zoom in here, that this measure and this measure, when added together, would equal 180. So not only are they next to each other, but they're also, when added, equal 180 degrees. So they're also supplementary angles. Okay? Last but not least, we were supposed to take a look at angles 1 and 2. So these angles right here. And you should have noticed that there are some perpendicular symbols right there. So angles 1 and 2 are not only adjacent angles, because they're right next to each other, but they are also supplementary angles. And last but not least, they're also right angles because they formed because the two lines, or the ray and the line, were perpendicular. So 4 and 6 are vertical and congruent. 8 and 7 are adjacent and supplementary. 1 and 2 are also adjacent and supplementary, but they're also right angles. And the only angle type that I did not show you in this diagram would be complementary angles, two angles that add up to 90 degrees. So that was probably the only thing I did not show you in this diagram. Okay? So this is how you would use this to help you. All right. It was my hope that you would go ahead and complete the assignment for 7-2. Okay? You were supposed to do 1 through 5 all, and then work through 6, 8, 10, 12. Okay, so we're doing the evens up to 24. Okay, and so you can see 24 ends right here. So you're doing 1 through 5 all and 6 through 24 the evens. This will be due Tuesday when you come to class. I hope this video helps, and of course, if you have any questions, you can always email me or contact me on my website at bclassroom.com. Thanks for watching, and I look forward to seeing how you do on this come Tuesday. Have a great day.